the IMU board is now soldered, and now we are reading positional data from it. On the left, you see that we have the raw data, and on the right hand side, you could see that we have the Kalman filter data. Now, of course, the MPU 6050, being an inexpensive electronic, does not give us very good information, which is perfectly fine since we're just having code at the time being. But on the right hand side, we could see that we are getting filtered noise, which is good for actually reading these electronics. So, if I wanted to give a better example of how much this noise could contribute, I'm quickly gonna go head out to the serial plotter. Curl Shift L, and now we have it open. Now, here, if you look closely, we have a blue line and a red line. The blue line is the raw data, and the red line is the Kalman filter. What I'm going to do now is just quickly vibrate it to just back and forth, none in the z-axis, just across the table, just like this kind of motion. So as we could see, the sensor raw data from these vibrations and the sliding motion is getting thrown off severely. We are not receiving very accurate data. But because of the Kalman filter, we have smoothed out data. This is important because if our control system is dependent on the IMU input and you use the dirty noise shown in blue, that would rotate the servos severely without actually representing any kind of interference in the z-axis, which, as I just demonstrated, did not move up or down. Thus there is no acceleration in the z-axis, although there might have been vibrational contributions to move it slightly so. Now, the reason why this update is probably one of the more important ones is because now that I have given you guys the raw serial data into a filtered data, I want you guys to just be wary that I am going to push this code soon to GitHub, and now we will be able to adjust our future coding projects off of this filtered noise, so that way we don't have such violent oscillations. Okay guys, in the next team update, I will be integrating the Kalman filter with the X and Y linear acceleration, and from there we could go ahead and do some pretty groovy stuff. Thank you guys very much. I will see y'all in the next time.